All right, so we're going to continue on with the lecture. We've talked about these concepts in earlier lectures, so this should just be a review for you. So, types of data. So you remember we have categorical or what we call discrete data, and this can be things such as gender, race, automobile type. Really anything that's better known by a name. This is referred to as nominal variables. Ordinal data is where you have some sort of rank order, like number of children, anything that can be categorically ordered. Certainly, and also like most commonly we see this as Likert scales, also can be rank ordered. ASA class is an ordinal level data. Now, quantitative variables, or sometimes what we refer to as continuous variables, are those things such as systolic blood pressure, height, weight, diastolic blood pressure, visual analog scales. These are things whose values are limited only by the precision of the instrument, and they're commonly measured with interval or ratio level data. All right, now we're going to move on to talking about choosing the right statistical test. Now, it was important that I review those concepts of levels of data because these concepts are important when we start talking about choosing a statistical test and choosing the correct statistical test. And the key things that you're going to see as we go continue on in this course is that the choice of the statistical test should be consistent with the purpose or hypothesis under study. You know, are you looking at describing something? Are you looking at associations? Are you looking at relationships? Are investigators trying to make predictions or detect differences between groups? These terms are very important as you all are reading the literature because they're going to help you in your appraisal process. You also need to ask, what is the measurement scale of the independent and dependent variables? Are they nominal, ordinal, or continuous? How are the samples related? Are the samples independent or are they dependent? Dependent variables, an example might be when you have a pre and post test design and you're looking at, say, maybe you're following a group of patients on a weight control program and you're looking at before and after participation in the program. And you want to compare mean differences in weight, but it's within those same subjects. So those groups would be dependent on each other, or sometimes we refer to that as paired data. What is the distribution of the dependent variable? Is it normal or is it a non-normal distribution? This is going to help you determine what type of statistical test. Typically, non-normally distributed data, we're going to use what we call non-parametric statistical analyses. And do the data meet the assumptions of the statistical tests? Throughout this course, we will touch on some of the assumptions that you need to be aware of for the statistical tests. We're not going to ask you to go through and run statistical analyses in software programs such as SPSS, but it is important that you understand the assumptions because many times these are referred to in the analysis section of a research manuscript. So how do you choose the correct or right statistical test? We got to look for those keywords. Are you looking at associations? Are they looking at median values? Are they looking at mean values? If you're thinking of if you see the term association, this will sometimes lead to you to test what we call chi-square or Fisher's exact tests or a McNemar's test. A median, if investigators are reporting median values, and this is typically used when you have non-normal distributions. This may lead you to using non-parametric tests, such as a Mann-Whitney-U, a Kruskal-Wallis, a Wilcoxon-signed rank test, or a Friedman's test. and if investigators are reporting mean differences in some sort of outcome, that leads you to what we call parametric tests, such as t-tests or ANOVA, or analysis of variance. So here is a flow diagram, and you can pause the video and look a little bit closer at it to get an idea. But I like how they broke this down by first thinking about the nature of the research question or hypothesis. Are you looking at differences, or are you looking at associations? Then they're looking at the measurement of the dependent variable or the research variable. And they're looking at the level of data that you're looking at. Is it nominal, ordinal, or interval ratio, or meaning is it continuous? Then you're going to look at how many groups are involved, or the levels of the independent variable. Do you have 1, 2, or more than 2 groups? And then what type of research design do you have going on? Do you have independent samples? Are they paired samples? Is important to think about, because that will impact the type of statistical test that you choose. And you can see that listed on the far right side of the figure. Here are some flow charts that you can pause the video. You can even print these out, keep them handy. I found them to be quite useful. Let me get my pen here to kind of help us go through it. So first thing you got to ask is, are you working with data that needs a statistical test? Yeah, sure. Now, if you're just doing descriptive, just simple descriptive statistics, and you're not running to compare differences between a group, not necessarily. Then you got to look is, do you have 2 discrete variables with few values? If yes, then maybe you're going to do a paired, and then you got to ask, are they paired or are they independent? If they're paired, you can see that we go to different tests here. If they're independent, you got to look at the sample sizes. Is either a Fisher's exact or a chi-square. So this is where we're looking at examples of association on this side, when you have 2 nominal variables. Now, if you do not have 2 discrete variables, then you got to look at, okay, what type of sample size do you have? If it's small, you probably want a non-parametric test. Now, then if it's not a small sample size, and then you got to ask, does at least one variable, is it normally distributed? If yes, you go do I have a discrete variable and 1 normally distributed variable? If yes, you're probably going to choose a parametric method. If not, meaning if you have, you may be going to correlation or regression analysis, which you'll talk about later lectures. So if we're going down the non-parametric path, are the samples paired, or are they independent samples? If they're independent, meaning there's no relationship between them, say pre and post measurements in the same group of individuals, they're independent. You have to ask, how many groups do you have? Are they 2 or more? You may lead you to what they call a Kruskal-Wallis, or if you just have 2, maybe Mann-Whitney U, and then you can make some sort of corrections for the test for multiple groups. Okay. Now, if the data is paired, then you can look at the distributions of the data, and you can see some of the different tests that we may do in there. The Bonferroni adjustment is where we're adjusting for multiple comparisons, and we adjust our p-value for that. Now, the parametric analysis, same thing, paired or unpaired. How many populations do we have, or groups? If you have 2 or more, we may be doing what we call an analysis of variance. If you have 2 groups, then we may be doing what's called an independent t-test. Now, if we do multiple tests again, we may need to make some corrections to the p-value. Now, if the data is paired, you may do what's called a paired t-test, which is equivalent to an independent t-test when you have paired data. And if you have 2 or more populations, it gets very complicated. And this is where some cases you may do what's called repeated measures analysis of variances, maybe where you're looking at differences in over time within the same group of individuals, or even sometimes between two or more groups. All right, so here's a list of some statistical tests that kind of going back, reinforcing some of these terms. Associations. This is where we have nominal and nominal level data. This is where you might use what's called a chi-square or Fisher's exact test. Is there an association between saline group presence or absence of motor block? So this is where you might have typically what we call a 2x2 table of dichotomous outcomes. Are there relationships? Meaning, when we think of relations, sometimes I think of correlations. This is where you might have a Pearson R or Spearman-Rowe is a non-parametric version of this. So is there a relationship between pain scores and morphine requirements? And we know from our clinical experience that yes, there is a positive correlation between those two. Are you looking at differences between groups? This is what may lead us, if it's a normal distribution, a t-test. Non-normal may be a Mann-Whitney U. If you have more than one group, an analysis of variance, or if you have more than one group or more than two measurements, you may do repeated measures and analysis of variance. Or a Kruskal-Wallis test if the data is non-parametric and you have more than one measurement. And if we're making predictions, this is where we're using regression analysis. Either simple, where we're trying to predict one dependent variable from one continuous variable, or we may have multiple regression where we have a number of predictor variables where we're trying to see if they predict an outcome of a continuous variable. A logistic regression is where we have a binary outcome and we're trying to predict that for some group of variables. And a survival analysis is where we're looking at time to events.